Today we're going to talk about the average rate of change. We're going to cover 3 sections today. All are leading to the concept of derivative. Everything we talk about is leading to the concept of derivative. All of the concepts that we're going to discuss in these sections today lead up to the idea of a derivative. So let's start by talking about change, an average rate of change of f over the closed interval AB. The idea we're going to discuss is that of a difference quotient, And if you took pre-calculus, you most likely will have seen this idea already. Okay, so let's start out here. The change in f of x over the interval AB, the closed interval AB, is denoted as delta f. We use delta to denote change n. So we read this as change in f. That's equal to f of b minus f of a. The average rate of change of the function f of x over the closed interval AB is given by the change in f over the change in x. That's equal to f of b minus f of a divided by b minus a. You'll need to know this. You'll need to be able to apply it. This is the average rate of change. Okay, so one thing is also denoted as or known as, it's known as the slope of the line through the points P and Q. So graphically what's happening, is that better zooming in? Okay, graphically what's happening is you have a function, f of x, you have 2 points P and Q. The point P is given by A, f of A. The point Q is given by B, f of B. And then the slope of this line is just the line going through the 2 points. Well, that's supposed to be a straight line. Okay, straight line going through those 2 points. That is a straight line, okay? A straight line going through those 2 points, okay? That is known as your average rate of change. A definition, a line through the points P and Q is called a secant line of the graph. Secant line. Okay, so notice that secant is derived from the Latin word secans, which means cutting. So it makes sense that it cuts through 2 points. Okay, so that's what's happening there. So you have the idea of average rate of change, and that's the slope of the line through the points P and Q, and then you have the secant line, which is the line through the points P and Q. Okay? The difference quotient, this is also something you need to know. If we let B be equal to A plus H, so remember, so let's just do an aside here. What is the average rate of change given by? What's the formula for the average rate of change over the closed interval AB? We just talked about it. F of B minus F of A over B minus A. Very good. So now for the difference quotient, it says let B be equal to A plus H. Then the average rate of change of F over the closed interval A to A plus H is given by the formula F of A plus H minus F of A all over, if you put in A plus H for B, notice that the A's will cancel out. So you're just going to be left with H. Okay? So you have a F of A plus H minus F of A over H. This is called your difference quotient. Okay? So now what we're going to do is we're going to go through an example where we are calculating the average rate of change. Okay? We're calculating the average rate of change. What questions do you have so far? Shaking your head no? None? Okay. So keeping it moving. Example 1. We're going to calculate the average rate of change of this given function here over the interval closed interval 0, 4. So I'm going to zoom in a little bit. Okay, so suppose we call the function in this example I, mainly because we're talking about inflation and budget deficit, which is the percentage of GNP. Okay, so here we want to find the average rate of change of this function over this interval. So using our formula, that's equal to I of 4 minus I of 0 over 4 minus 0. What is I of 4 equal to? $2.5. Very good. I of 4 is 2.5. What is I of 0? 2. Very good. So you have 2.5 minus 2 over what? 4. You got it. Enter that into your calculators or calculate it by hand. You get 0.5 divided by 4, which will give you 0.125 percentage point increase. So let me move this up a little bit. So that would be a 0.125 percentage point in inflation per 1% point increase in the deficit. Okay? Part B. Part B. Given f of x is equal to 2x squared plus 4 over the closed interval -1 to 2, find the average rate of change of this function over this interval. Would you like a minute?
Yes.
Good. So recall here for part B, when you're finding the average rate of change over this closed interval, you said the formula is f of b minus f of a over b minus a. It helps to know what a and b are here. What is a? A is equal to -1, and b is equal to 2. Very good. So here we have f of 2 minus f of -1 divided by 2 minus -1. F of 2, what did you get? 12. Very good. And then you're subtracting f of -1. What did you get for f of -1? 6. Good. All over 3. So you have 6 over 3, which is 2. Good. What questions do you have? Okay, so now what we're going to do, we're going to go through an example where we're finding the difference quotient. We're going to find the difference quotient. What is the formula for the difference quotient? What's the formula for the difference quotient? Yes?
F of A plus H minus F of A over H.
Very good. F of A plus H minus F of A all over H. So now what we have to do is we have to find that for the function f of x equals x squared over 2, then evaluate it when a is equal to 1. So I would take this in several steps. Okay, first things first, we can find, and you choose whatever you prefer. You can find it all at once, or you can take steps by finding f of a plus h, finding f of a, then finding the numerator, and then putting it all together. Which do you prefer? Doing it all at once or taking steps?
Taking steps to start.
steps? Okay, sounds good. So, f of a plus h is equal to the quantity a plus h squared divided by 2. So what we did here, we took a plus h, substituted it in for x here. Okay? Now, what is a plus h quantity squared? What's that equal to?
A squared plus
Good,
plus
good. All over 2. So we have a squared plus 2ah plus h squared all over 2. Okay? Then you find f of a. F of a is equal to a squared divided by 2. It is what it is. There's nothing else for us to do with that. Now we find f of a plus h minus f of a. So we take what we got for f of a plus h. That is a squared plus 2ah plus h squared, and we divide that by 2. Then we subtract f of a, which is a squared. That's an a. Can make the a look a little bit better. A squared divided by 2. Simplify. What happens to the a squareds? They cancel out, right? So we're left with 2ah plus h squared all over what? 2. You got it. Good. Now, this is our numerator. What we found is our numerator. Now we put it all together to find our difference quotient. So that means that f of a plus h minus f of a all over h is equal to 2ah plus h squared over 2, all of that over h. Now that looks a little bit weird, okay? So what we're going to do is we're going to rewrite it. Before we rewrite it, let me rewrite the numerator. The numerator of f of a plus h minus f of a, they have an h in common. So that's h times the quantity 2a plus h, all over 2. Dividing by h here is the same thing as multiplying by what? 1 over h. Very good. So that means this is equal to h times 2a plus h all over 2 times 1 over h. What happens with the h's? They cancel out. Good. So you're left with what?
2a plus h over 2.
Good. 2a plus h over 2. So we found the difference quotient. All of that to say the difference quotient is 2a plus h divided by 2. It's 2a plus h divided by 2. Now, the second part says evaluate it when a is equal to 1. When a is equal to 1, what do we get? We get what? How did you get h, you said? You, right, you'd get 2 plus h because, yes, you do plug in a equals 1 in here. And when you do, you have 2 times 1, which is 2, plus h divided by 2. So you'll get 2 plus h divided by 2. So that's the second part.
Cancel out 2.
No. Remember, the only way, so the question was, can we cancel out the 2? The only way that we can cancel out a 2 is if both terms in our numerator has a 2. So the only way we could do that is if we had 2 plus 2h over 2. Then we'd be able to factor out a 2, and that would leave us with 1 plus h over 2, and then we could cancel. But because we do not have that here, we can't. So this was just to answer a question. What other questions do you have? Okay, all right, so now let's go through another example. Let's go through another example. Example 3. The following table shows education expenditure in the United States as a percentage of total federal spending in 2009, 2015, and 2019. So the year T is given by the year since 2000, so we have 9 for 2009, 15 for 2015, and 19 for 2019. The percentage, P of T, for 2009 is 25, for 2015 is 27, for 2019 is 26. Compute and interpret the average rate of change of P of T over the period 2009 to 2019. That is over the closed interval 9 to 19. So here, what we want to do, since we're finding the average rate of change, the formula, what would that be whenever you apply it to here, given that the function is P? P of what? P of 19. Continue.
Minus P of 9
Mm-hmm.
over 19 minus 9.
Over 19 minus 9. Very good. What's P of 19? 26. Good. P of 9? 25. Good. Over 19 minus 9, which is 10. Good. So we have 1/10. So that means that we have 0.1% per year. So what this means is the U.S. education expenditure is projected to have increased an average rate of 0.1% per year during 2009 to 2019. Do you need me to say that again? Okay, so that means that the U.S. education expenditure is projected to have increased an average rate of 0.1% per year during the years 2009 to 2019. Got it? Need me to say it again, or you have it? Thumbs up? Okay. All right. Do B. Do part B and interpret it. So over the period 2015 to 2019, that's given by P of 19 minus P of 15 over 19 minus 15. That's equal to 26 minus 27 all over 19 minus 15. Or in other words, we get negative 1/4, which is negative 0.25% per year, which means that the U.S. education expenditure is projected to have decreased at a rate of 0.25% per year during. So we have it that it's decreased at an average rate of 0.25%. So whenever you say it's decreasing, you don't have to say negative 0.25. You just say it's decreasing at a rate of 0.25% per year. Okay? Does that make sense? All right. So that's section 10.4. That's section 10.4.